All right. Good morning or afternoon to Algebra 2 Semester 2. We are talking about log properties. So last time we were introduced to logs, okay, it's kind of another type of function we're going to talk about here, and we're just going to go over a couple of properties that logs have. There are three of them we're going to talk about: product, quotient, and power properties. So please have some paper, pencil, and get ready to take some notes. All right. So the first thing is the product property of logs. Okay, so if you got a log with some base a, and it's a product of two things in the middle. Okay, your argument here is a product. Okay, you can separate it into two factors, x and y. Then you can also rewrite it as log base a of x plus log base a of y. Okay. In other words, I can split those two factors apart and separate them log-wise as a addition problem. Okay. Quotient property of logs is pretty similar. You may guess where this one's going. If you've got two numbers that are, you can divide, you can separate that out into log base a of y. Whoops, not plus. It should be a minus sign. I missed that one a little bit, but it should be a minus log base a of y. Okay, where the y is the thing you're dividing by, so that goes in the bottom. Okay, as the minus part. So that does matter. This one doesn't really matter as far as order goes because we're not carrying too much to the same sign probably. Last one here is the power property of logs, and this one is pretty simple. If you got x to the yth power, okay, you know that you can separate your or rewrite your argument as a exponent. Then you can simply separate them by putting the exponent out front, y times the log base a of x. Okay, so those are our three properties here, and we're going to use them to expand and condense different expressions involving logs. So let's take a look at these couple ones right here. Here we have log base 6 of 3x. Okay, expand the expression. Those are my directions. Expand the expression. So let's take a look here. Log base 6 of 3x. So my argument 3x, well, that is, of course, 3 times x. Okay, at least you should know that one. And so when I want to take it apart, okay, then I can go and split it into log base 6 of 3 plus log base 6 of x. Okay, and that'll be my answer right there, nice and simple. Okay. There's no need to really evaluate these two things, although you could certainly plug that left one into a calculator to figure out what the value is. Okay, but we don't need to do that right now. What we're doing just right now is just expanding the expression. Alrighty, let's take a look at the second one here. Log base 2 of x over 5. Well, this one's a dividing problem now, right? So I'm going to be using a different color here. It's x divided by 5, right? X over 5. So when I rewrite it, I got to use that second one. Log base 2 x minus log base 2 of 5. And that's my answer. All right, really easy examples so far. Let's scroll a little bit down and see what else we've got. All right, here we have a couple more problems. There's a little more things happening in these ones. And then we got a couple of challenge logs. So we're going to be talking about those as well. Because really, this rule can be applied over and over and over again. You don't just have two things, right? Maybe you have three things, four things, multiplying, adding, dividing. Okay. And we can separate them all out no matter how many there are, because that rule works no matter what. So here we go. Log base 4 of xy over 3. Well, there's three pieces. There's three factors there. Okay, I got my x, I got my y, and I got my divided by 3. So when I try to expand this, let's just do it one piece at a time. Okay, one piece at a time. I know I'm going to have log base 4 in my expanded forms. So I'll go ahead and write that first. But when I look at my argument, my x, y over 3, that is x times y divided by 3. Well, let's go ahead and just take these apart one by one. X and y, that I can be splitting apart by adding. Okay, so there's my first part. But I still have that divided by 3 part. So I'll have to have a log base 4 minus 3 there to see how that works out. Okay, And I think you can't really combine these things together. They don't have the same argument. So I think that's our answer right there. Notice they all still have the same log base. Okay. You can't do this if they don't have if they have different log bases, okay, but you won't deal with that necessarily too much. Number 34, let's try this one. Log base 5 of 2 square root of x. Now this is definitely a tricky one because you can't just leave that square root sign in there. We're going to have to get rid of it somehow. So first let's figure out what we need to expand here. This is 2 times the square root of x. Okay, seems simple enough. Let's go ahead and take it out. Log base 5 of 2 plus log base 5 of square root of x. Well, I said earlier though that we can't leave square root in our form. Okay, but remember from earlier, we can actually rewrite this as an exponent. Okay, using our radical rules, you should know this is x to the 1/2 power, right? Same thing, right? So finally, when all is said and done, I'm going to have log base 5 of 2 plus, remember the rule up there, got to take my exponent out, put it in front. 1/2 times log base 5 of x. And that will be our final answer for that problem. Okay, so a little more involved, a couple of two-step equations there that we can expand. Okay, let's try one of the problems here. Okay, one of the challenge problems, and then the other one I'm going to leave for you just in case you want to give it a shot. All right, so let's take a look at this one. I've got log base 3 of the 4th root of x times y over z squared. Woo, that's a mouthful. Try saying that a couple times fast. Well, it doesn't seem that challenging, I think. We got the 4th root of x times y, and then we have it divided by z squared. Okay, so let's separate all these pieces out first, kind of like with number 33. I've got log base 3 of not cube, 4th root x plus log base 3 of y minus log base 3 of z squared. Okay, but we have some pesky exponents, so we're going to have to get rid of them the only way we know how, with the power rule of logarithms. Okay. So in this one, just like in the number 34, this is technically the same as the 1/4 power, so I'm just going to kick it out here, 1/4 log base 3 of x plus log base 3 of y minus, this is a 2, and I don't need to do anything special with that one. I'll just kick it out here. 2 log 3 of z. And there we go. There's our challenge problem. Okay. So when in doubt, just write out your whole little line of mathematic work with multiplication division. Replace the multiplication division by pluses and minuses, add your logs in, and then if you have any powers, kick those out to the front as a coefficient. That's the first part of this lesson. Let's get to condensing some exponential. All right, now we're going to be condensing. Okay, condensing meaning I want to put it all under one log, just one log. So first of all, we need to check, do they have the same base? And I think the case will be for all of these that they do, in fact, share the same base. Okay, actually, hang on. This one doesn't seem to be the same. Log base nothing of x, log base 2 of y. So we'll talk a little bit about that one. Okay, so let's see here. We got log base 3 of 7 minus log base 3 of x. Alrighty. Those are the same log, so I should end up with log base 3 of something. 7 minus x. Okay, so 7 divided x. There's my answer. Undoing the rule. Very simple. Alright, next one we have 2 log base 5 of x plus log base 5 of 3. Well, this was a little more involved. I'm going to have to get a little bit creative here. So first, I got to put this 2 back where it belongs by exponent rule, the power rule. Log base 5 x squared plus log base 5 of 3. So using the power rule, I got that in there. We have the 5 and the 3. And then we just combine those things together. Log base 5 of x squared times 3, or more appropriately written, log base 5 of 3x squared. Okay, so that one was a little more involved, but we still got it down to our single form, one term, log base 5, 3x squared. All right, now in number 37, I can almost guarantee you this is supposed to be a 2 right here, okay, and not just nothing. But let's suppose you do have different bases. Well, then you would use this thing called change of base formula, which we're not going to go over, but just know that if you plan to pursue higher math, okay, or you're forced to take a higher math class after this, they may teach you the change of base procedure here, but I'm not going to be covering it. I'm just going to assume there's supposed to be a 2 there. So 1/2 log of x minus 3 log base 2 of 1. All right, again, you got to put these numbers out here back up in the exponent slot. So we got log base 2 of x to the 1/2 power minus log base 2 y cubed. Then just combine our things. Okay. Log base 2 x to the 1/2 divide by y cubed. And finally, clean it up. Don't leave that 1/2 in there. Log base 2 square root of x over y cubed. Okay, so try to make sure you're following the conventions of our nice simplified forms. You don't want any fractional exponents, and you don't want any numbers out here in the front either. Alrighty, last one here. Log base 3 of 4 plus 2 log base 3 of x minus log base 3 of 5. There's 3 parts again. Remember, if you get a little if you are a little bit on the struggle bus, you can always rewrite this using the pluses and minuses as multiplication and division. Okay, so first of all, I'm considering my 4 here as my argument for log base 3 of 4. Then I have x, but I have to remember this 2 has to go back up here, so x squared in my second one, and this one is just 5. So here's multiply, here's divide. So when I look at what I got, I've got log base 3, 4x squared all over 5. And those are all the pieces I covered. So that is that. Okay. There are a couple of challenge problems with this one as well. Okay. But honestly, I think we've kind of covered enough here where I am comfortable leaving you off. That's really all we did today. That's all we really need to do is be able to expand and condense your logarithmic expression using the 3 rules from the beginning of the video. So make sure to do a couple of extra problems here attached to the notes video, and I'll see you in class.